Welcome to WSHS Algebra 1 Virtual Tutor. Today we are going to be talking about functions. Our vocabulary words, we start off with blank, are all of the input for the x values, and our word here is the domain. So domain goes with the x values, which means range is all the output values for the y values. So we call this our range. So range is our y, so r equals y. And a way I remember it is x comes before y, d comes before r, so d goes with x, r goes with y. A function is a relation that assigns exactly one value in the range to one value in the domain. In order for something to be a function, the biggest thing is the x values can't or cannot repeat. And the vertical line test allows us to analyze a graph to see if it is a function. The vertical line test can only touch the graph once for every vertical line drawn in order for it to be a function. So for a quick example, let's make two graphs. I have a circle and I have a line. The vertical line test, remember, vertical line goes up and down. Okay, so when I go and draw my vertical line with my green marker, I'm asking myself, how many times does this green marker touch this graph? It touches once, but then it also touches twice. So that means that this is not a function. Okay, a circle is not a function. But if I go over to my line here, and I make my vertical line going down, and I look, it only touches my graph once. If I draw another vertical line, again, it only touches my graph once. So yes, this is a function. So that's what it means by doing your vertical line test. And you only do your vertical line test when you're given graphs. Example 1 says determine the domain and range. So again, it's asking you for x and y. Okay, domain is x, range are your y's. So when you're given an ordered pair, remember an ordered pair is x, y. So all you have to do is label all of your x's. So what comes first in your ordered pair? So I would say 1, 2, 4. And your range are your y values, which are 1, 3, and 5. And that's how easy it is. Now, when we have a line, we get a little bit more complicated, okay? So if I asked you what your domain is, this line is continuous. It goes on forever and ever. So with domain, you're looking how far left and how far right does it go? So if I cover up my y-axis, I'm asking myself, to the left, how far down does it go? Well, it looks like it's at -6, but because it has these arrows on that I added, it is going on forever and ever. So it is eventually approaching negative infinity. And then if I look to the right of my hand, does this line keep going on forever and ever? It does. And then from there, it's approaching positive infinity. So we can write our domain in two ways. We can write our domain as domain equals, and this fancy r. So it's two vertical lines going down and then the r. This represents all real numbers. Or you may see your domain written as an inequality, and your inequality would be negative infinity less than or equal to x, because x is our domain, that's what we're looking at, is less than or equal to positive infinity. So either answer works, just be aware of both. Now for our range, It's the same idea. You ask yourself, how high does this graph go? And does it go on forever? And then you ask yourself, how low does this graph go? So I'm going to make my red line here. And again, how far up does this graph go? It goes on forever and ever, so it's approaching infinity. How low does it go? It goes on forever and ever, so it's approaching negative infinity. So again, our range is all real numbers, or negative infinity less than or equal to y less than or equal to positive infinity. And this is kind of a harder concept to understand. So basically, if it doesn't have a stopping and ending point, they're approaching infinity and negative infinity. If you look at letter C, if you're giving ordered pair dots as your graph, you can make vertical line test. For every vertical line you touch, it can only go through one point. So every vertical line I'm making at my points only goes through once. So yes, this is a function. But it's not asking, not only is it a function, it's asking specifically what the domain and what the range are. So all you have to do is, I find it easiest to make a table of what your domain and range are. So what are your x values and y's? So this graph is slightly off, so your point should be at the nice whole numbers here, not. So if we look at it here, our first point here is negative 1, 2, 3, 4. So you're at negative 4 and down to negative 1. Our next point is at negative 3 and up to 1, 2, 3, 4. Negative 3 up to 4. Our next point is at negative 1 and down to negative 3. Our next point is at positive 3 and up to positive 2. And our last point is over to 4 and down to negative 2. So for our domain, you just take your x values, negative 4, negative 3, negative 1, 3, 4. And for your range, you take your y values, negative 3, negative 2, negative 1, 2, and 4. So that is your domain and range for letter C. Now for letter D, you have your quadratic here. So first things first is your domain. How far left and how far right does it go? So this quadratic has arrows at the top of it, meaning it will go on forever and ever in both directions. When it's going on forever and ever in both directions, your domain will be negative infinity less than or equal to x less than or equal to positive infinity. For our range, though, our range is something a little bit different. If I ask myself, how low does this graph go, you would say it goes down to negative 1. There's no part of my graph below negative 1. So that means we write our range as an inequality as well, but it's going to be y has to be greater than or equal to negative 1. This inequality represents any number for the y value that is bigger than negative 1. And that's what we want. That's our y values. Our y values are bigger than negative 1. Nothing is below negative 1. Now, for letter A, on the u-try, f of x equals 2x minus 5. In order to complete this, we have to use our graphing calculator, and we have to graph it. So we graph this by pressing y equals and plugging in 2x minus 5. So I've brought my calculator up. I'm going to turn it on, and I'm going to press y equals. I'm going to clear whatever's in there right now. And I'm going to plug in our function 2x minus 5, and I'm going to hit graph. And you can see that this is a line, and this line is continuous. So because this is continuous, this now means that my domain is going to be all real numbers. And my range is also all real numbers. There is no particular point where this line stops. For letter B, again, I have arrows on my line, my quadratic, excuse me, and I'm asking myself, does it keep going? Yes. Is this going to pass and go through towards negative infinity? Yes. Is it going to go towards positive infinity? Yes. So you can write your domain again as negative infinity, less than or equal to x, less than or equal to positive infinity. Now for your range though, again, you're asking yourself, how low does this graph go? This graph goes as low as 1. Does it go any lower than 1? No. So we're going to represent this with an inequality as well. And we want every value greater than or less than 1. Well, because our graph is going up, we want all the values greater or equal to 1. For example 2, it states state whether each relation is a function or not a function. So for problems like this, you're asking yourself, does my x repeat? If your x value repeats itself and goes to a different y value, it is not a function. So if I look at all my x values here, I have a 1. Does the 1 repeat in the x spot? 2, 3, 4, 5, 6. No. Then I have a 2. Does my 2 repeat in the x spot? 3, 4, 5, 6. No. 3. Does it repeat in the x spot? No. 4, 5, 6. 4 doesn't repeat, 5 doesn't repeat, 6 doesn't repeat. So yes, this is what we would call a function. Letter B, we have a representation of a mapping. A mapping, your first circle is always your x's, your second circle is always your y's. In this, when you have arrows coming off, it's mapping to a particular y value. 5 is being mapped to 1, and it's being mapped to 2. 6 is being mapped to 2, and 8 is being mapped to 2. Well, because you can see that I have 2 arrows coming off of my 5, that means my 5 value is repeating, and it's going to 2 different numbers. It cannot do that. It cannot go to 2 different numbers, so this is not a function. If we look at letter C, we have a table of values. Really easy. It's clear cut. Our left column is x, our right column is y. And I'm looking to see, do my x values repeat? 0? No. 1. 1 goes to 2, and then if I go down here, I see another 1. 1's going to 1 and 2 and 1 to 6. That is not a function. Letter D, we have our vertical line test. Okay, so this is where we draw vertical lines on our graph. So I'm going to make my first vertical line here in red. And when I do this, you can see it only touches once. You need to make more than one vertical line. I'm going to make my second vertical line here. And when I make my second vertical line, it passes through 1, 2, 3 times. So because it touches my graph 3 times, this is not a function. Now for the you try, you can make vertical lines at your points, or you can label all of your points and see if your x values repeat. But for every vertical line I made, it only touched 1 point. If it's only touching 1 point for every vertical line, it is a function. If I look at letter B, I have a table, real easy. 0 doesn't repeat, 1 doesn't repeat, 2 doesn't repeat, but 4 repeats. 4 is trying to get with 6 and go with 8, and that's not allowed, so that's not a function. So long story short, x cannot repeat. Example 3 says, given a function represented in some other form. So you can represent it with a table, a graph, ordered pairs, a mapping, are all different representations. We have y equals 3x plus 1. So this is a good representation to do with a graph, if you would like. Okay, so let's make our graph here. And I'm going to bring up my graphing calculator to rewrite what this graph would look like. So I'm going to put in 3x minus 1 into y equals, and I'm going to hit graph. And now I'm just going to replicate what this graph looks like. It looks like something going like so. And that's one representation. Letter B, we're given ordered pairs on a graph. So I'm going to label what these ordered pairs are in an XY table. So I'm finding my first dot. My first dot is at -3, 0. My second dot here is at -2, 4. Then we come down and we're at 0, -4, and over 3 and at 2. So that's a different representation there. And then for the U-try, you're given a table. Let's make a mapping. So we have x's and we have y's. So we have 0, 1, 2, 3, 4, 0, 2, 4, 6, 8. And in our mapping, we're drawing arrows to the correct number. So 0 goes with 0, 1 goes with 2, 2 goes with 4, 3 goes with 6, and 4 goes with 8. So there's another representation for functions. We have no additional notes. It says determine the domain and range for the function. So again, we have lines. When we have lines, unless it's indicated, and you can clearly see where that line starts or stops, your domain will be all real numbers, and your range will be all real numbers. Here we have a quadratic. And our quadratic for our domains will always be reaching -infinity and +infinity, or all real numbers. I'll write it the other representation as well, just so you can be familiar with it. And for our range, this one's a little bit different from our examples in our notes. Instead of how low does this graph go, we ask ourselves, how high does this graph go? This graph goes all the way up to 4. Do we want values more than 4 or less than 4 to represent our graph? We want them less than, so we want to say less than or equal to 4. So that's our range. Number 3, we're going to list what our domain values are, and we're going to list what our range values are. So we're just labeling the ordered pairs. We have -2. We have -1, 0, 1, and 2 for our domain. And our range is going to be 2. If it repeats, so 2 and 2, you only need to list it once. So 2 and 2, so I'm just going to list that once, 0, -2, and +1. So that would be your range. Number 4, this one's a little bit different. Our domain. You ask yourself, how far left does this graph go to? This graph goes all the way to -3. And we set it up as an inequality because we want to represent everything between -3 and how far right does it go? It goes all the way to +3. So this represents this point, that point, this point, this one, everything on that line, you're now representing in that inequality. For our range, it's very similar, but instead of how far left and right it goes, how far up and down does it go? So you first want to look at how low does it go? It goes to -4, less than or equal to y, less than or equal to, and then how far up does it go? It goes all the way up to 4. Okay, so remember, range is up and down, And domain is left and right. For number 5 and 6, we need to plug those into our calculator. Again, it's still asking you what the domain and what the ranges are. So for 5, we're going to plug this into our calculator. We're going to say y equals again, we're plugging this into our calculator under y equals, so we're going to clear out our expression, and we're going to plug in x squared, so x squared plus 6x. My x didn't show up, so I'm going to clear this out. Try this again. X squared plus 6x plus 12. And now I'm going to hit graph. Again, we're trying to find the domain and range here. Oh, we have a quadratic. If you haven't realized by now, quadratics, your domain is always going to be all real numbers. Negative infinity less than or equal to x, less than or equal to positive infinity. Now we have to see specifically how low does this graph go to. 1, 2, 3. It goes as low as to 3. And then we want everything up. So again, we want everything above 3. So your domain is negative infinity. Let's try that again. Negative infinity less than or equal to x, which is less than or equal to positive infinity. And your range is y is greater than or equal to 3. Again, we want everything above 3. For number 6, again, we're going to plug this into our calculator. And when you plug it into your calculator, you should get a line. A line that looks something similar to this. So if we look at this line, and our domain is all real numbers, so it's approaching negative infinity and positive infinity, and the same thing with your range. Number 7 says determine if each one of these below is a function or not. Again, you're trying to see if your x value repeats. I have 0.8. Do I have 0.8 again for x's? No. I have 1.2. Do I have 1.2 again? No. I have 3.5. Do I have 3.5 again? No. So this is a function. Number 8, we have a vertical line. When I go and make my vertical line, on top of my vertical line, this red line is touching the black line underneath it everywhere. So because it's touching everywhere, this is not a function. And not only that, ladies and gentlemen, if you decided to look at this and make some points on this line, let's say I want the point right here and the point right here and the point right here. Your x value is 1.5 and your y value is 2. When I come down to make my next point, my x value is still 1.5, and now my y value is 0. So because my x value is repeating itself right there, it tells you that this is not a function. That wraps up functions about domain and range. Please take the time to do the practice so you have adequate practice on all of it.